Section 7.2, Applications of Venn diagrams. Draw Venn diagrams and shade the regions representing each set. So I've got two circles representing a Venn diagram like we saw in the last section. I'm going to label the left one A and the left one B, and just kind of out here U. And remember, U represents the universal set. And again, the universal set represents all elements in A and in B, and those items that aren't in A and B as well. So let's shade those items that are not in A but yet intersect with B. So if we talk through the items that aren't in A, if they aren't in A, then those items would be in either B or the universal set. So if they're not in A, then they would have to be out here, or they would have to be in here. But if we want to intersect them, what does the universal set and set B have in common? Well, that would just be set B itself. It wouldn't be the set outside, because we want to find, when we intersect, remember, to intersect items, they have to be items that they both share in common. So the items that they both share in common from the universal set and set B are the items in set B. So we would only want to shade set B. Let's find the items that are not in A and bring them together with the items that are not in B. So if I have items that are not in A, we should ideally label A and B. So here we have A, B, and the universal set that's containing all of them. So if they're not in A, they would have to be the universal set, because that's not in A. And it would have to be items here. So if they're not in A, they're the universal set and B. We want to combine that together with the items that are not in B. Well, if they're not in B, then it would also be the universal set, which we only need to count one time, and then the items in A as well. And remember that the union sign, this sign here, also can mean or. So it can be not in A, or not in B, or not in A and B together. Okay, let's do A union not in B. So we have A, B, and the universal set. So remember, union is what they have all together, so their elements all together. So we have the elements of A, and combine that with the elements not in B. So if it can't be in B, we have to have the universal set of not in B. And we can include these items here. And by doing so, that also includes the elements of A, by doing this. So the elements in A combined with the elements not in B. So not in B are the universal set and then the set A. Combine that with the set A. So here. We cannot color this area, because this area would be included in B and it cannot be in B. So don't include the middle area. Let's talk about three circles. When we talk about three circles, we have to have an A, a B, and a C. So A, B, C, and then again we have the universal set. Okay. Let's do the part B not in C. B intersect not in C. Looking at the part that's in parentheses, B intersect C prime or C complement. So looking for items that are in B intersecting with items that are not in C. So using what we know from the first example, from the previous problem, we can color in, if they're not in C, then they're in B. So we're going to just, first right now, just color elements of B here. We now have to tackle the complement of A, so items that are not in A that are combined with B intersect C prime. So keep in mind that because this word means or, we cannot have, we don't want to shade in all of A, all of the circles in A, but we can include this part here because that part's not associated with A. But because of the or, it could be associated with B. That one was a tricky one, so be careful when you're working with these three items. And let's tackle not in A intersect B union C. So we'll have to identify our A, B, and our C again. So A, B, C, and then the universal set hanging around out here. We know that the intersect means and, so what do they both have in common? And the union means or. So let's first tackle B or C. So if we did B or C, that would include all of these items. B or C, or B and C. Okay. But now we need to tackle the items that are not in A, that combined, what do they share in common with these items here? So items that are not in A, but share items with these items here. So that would mean that we would have to get rid of this portion here, because those portions are in A and we can't have them together. And then the portions that share in common are already the highlighted portions. The three items can be more difficult than the two Venn diagram ones, the two circle Venn diagrams. So if you have any questions, please make sure you ask me and we can go over them together. They can be tricky. Okay, so a researcher collecting data on 100 households finds that 76 have a DVD player, 21 have a Blu-ray player, and 12 have both. And we want to answer the questions below. How many did not have a DVD player? How many have neither a DVD player nor a Blu-ray player? And then how many have a Blu-ray player but not a DVD player? So we're going to label our items as DVD and Blu-ray. And then, of course, the universal set, those who don't have Blu-ray or DVD. When I work through these problems, I always like to start at the bottom and work my way to the top. So if they have both a DVD and a Blu-ray player, that 12 will go in here because that contains a DVD and a Blu-ray. For those who have a Blu-ray player, that would be the right-hand circle, but we have to take in consideration the 12. So 21 minus 12, that means 9 have a Blu-ray player. So 12 plus 9 would give our 21. 76 have a DVD player. But again, just like the Blu-ray player, if we have 76, we have to subtract the 12 that are already included with the DVDs. So 64 have a DVD only. So we have 64 that only have a DVD, 12 that have both a DVD and a Blu-ray, and then 9 who only have a Blu-ray. But we have 100 in our household. So if we were to take 100, subtract 64, subtract 12, and subtract 9, there are 15 left over that don't have a DVD or Blu-ray player. So now we can answer the questions. How many do not have a DVD player? How many do not have a DVD player? Well, if you have a Blu-ray player only, and we have the universal set where they don't have a DVD player, that means 24 do not have a DVD. How many have neither a DVD player nor a Blu-ray? So how many are not in our circles? Well, that would be 15. 15 people do not have anything. How many people have a Blu-ray player but not a DVD? Well, that would be just Blu-ray only. We can't include the 12 here because that's in combination with those that have a DVD. So there are 9 people, or 9 households that do not have a DVD player. Here, a survey of freshman business students at a large university produced the following results. 25 students read Bloomberg Business Week. 19 read the Wall Street Journal. 27 do not read Fortune. 11 read Bloomberg Business but not the Wall Street Journal. 11 read the Wall Street Journal and Fortune. 13 read Bloomberg Business and Fortune. And then 9 read all 3. So, let's label this one Bloomberg. We can label this one Wall Street. And the last one Fortune. And the universal would be those students who don't read any. So first of all, again, we start at the bottom and work our way to the top. So 9 read all 3 of them. So that's the very middle that contains Fortune, Bloomberg, and the Wall Street. So that one's done. 13 read Bloomberg Business Week and Fortune. So 13 read Bloomberg Business Week and Fortune. So we have to go to where Bloomberg and Fortune meet, but we have to take into consideration the 9 that already exist in this kind of semicircle. So 13 minus 9 is 4 who read Bloomberg and Fortune. 11 read the Wall Street Journal and Fortune. So we go where Wall Street and Fortune meet, so there are 11 here, but we already have 9 that are already reading both, but including Bloomberg. So that would give us 2 in this category. And this one is done. It says 11 read Bloomberg Business Week, but not the Wall Street Journal. So 11 read Bloomberg Business Week, but not the Wall Street Journal. So if we go to just Bloomberg, we don't even have to take into consideration the middle 9 here because that would include those who read the Wall Street Journal. So we can assume in here would be 11 minus 4, the ones who read Bloomberg and Fortune. So there are 7 that read just Bloomberg only. We also have 27 who do not read Fortune at all. We have 27 who do not read Fortune, which means that if they don't read Fortune, they could read Bloomberg or Wall Street. So we can use that to take into consideration the Wall Street here. So if we have a total of 77 students and we subtract the 27 who don't read Fortune, we ended up with 50. But we have to take into consideration the 4, the 9, and the 2. So we'll subtract 4, 9, and 2, and that there will be 35 who only read Fortune. So that one's done. We have 19 that read the Wall Street Journal, and 25 students who read the Bloomberg Business Week. Before we can finish the Wall Street, we'll need the 25 students that read the Business Week so that we can finish filling in this box here. So we'll take 25 minus 7 minus 4 and minus 9 and get a total of 5 students so that we can fill in that box. And then 19 students read the Wall Street Journal. So if 19 students read the Wall Street Journal, we'll have to take 19 minus 5 minus 9, and minus 2 to get a total of 3 students who read just the Wall Street Journal. So based on what we know from our circle here, we can answer some questions. How many students read none of the publications? Oh, but we have to fill in our universal set. So we'll want to take 100, because we have 100 students. Oh, I'm sorry, we have 77 students altogether. And we want to subtract each and every one of these numbers from 100. Because if they're not in those circles, then what's left over is people who don't read any. So when you subtract those numbers, you should get 12. So 12 students read none of the above. How many read only Fortune? There are 35 who only read Fortune. We can't count the overlapping ones because that would mean that they read other things as well. So just 35 read only Fortune. How many read the Bloomberg Business Week and the Wall Street Journal? So here. But not Fortune. So we can't count the 9 here because that would mean they read Fortune. So only 5 read the Bloomberg Business Week and the Wall Street Journal, but not Fortune. Let's try another one of these examples. This one's by far much more easier, I think, in my point of view. There are 100 students were asked which fast food restaurants they had visited in the past month. How many ate only Taco Bell? So we have one question. How many only ate Taco Bell? It looks like we ate at McDonald's. We ate at Taco Bell. And we ate at Wendy's. So again, starting at the bottom is the easiest way to tackle this. So 13 ate at all 3. So 13 ate at all 3 restaurants. So that one's done. 22 ate at Wendy's and McDonald's. So at Wendy's and McDonald's. But there are already 13 that are included. So we're going to take 22 minus 13. So there are 9 that ate at Wendy's and McDonald's. But 9 plus 13 also includes all of them. 19 ate at Taco Bell and Wendy's. So Taco Bell and Wendy's. We already have 13 there. So 19 minus 13 gives us 6. 17 ate at McDonald's and Taco Bell. So McDonald's and Taco Bell were 17. So if you take 17, subtract 13 that are already there. So 4. 44 ate at Wendy's. But we have 9, 13, and 6 we need to take into consideration. So 44 minus 9 minus 13 and minus 6 gives us a leftover of 16. 46 ate at Taco Bell. But again, we're taking consideration 4, 13, and 6. So we'll take 46 and subtract 4, subtract 13, subtract 6. So a total of 23 ate Taco Bell. 47 ate at McDonald's. So again, we have 47 total. We have to subtract the 13, the 4, and the 9. So 21 ate only McDonald's. How many ate only at Taco Bell? 23 ate only Taco Bell. We cannot include these numbers here because that would mean that they ate at Taco Bell and McDonald's, Taco Bell and Wendy's, or all 3 of them at the same time. So we only want those who solely ate Taco Bell, which is 23. One more slide here. The union set of rules states that if we have A union B is equal to the amount of A plus the amount of B minus the amount of A intersect B. So if I have A and I have B, and I know what A union B is, let's substitute so that we can find A intersect B. And it looks a lot harder than it really is. So I know A is 5. So where I see that part of my formula, I'm going to insert it there. I'm going to put the B portion here. And I'm going to put this portion here. So then all I have to do is solve for the remaining one. So I'm going to replace NA union B with 10 equal to NA, we're going to substitute that with 5, plus NB was 7, and then we're going to subtract NA intersect B since we don't know what that is yet. We can add our numbers together, so 10 equals 12 minus NA intersect B. We'll just start getting A intersect B by itself. We'll subtract 12. So negative 2 equals negative N A intersect B. And if our goal is to get this part by itself, we're going to divide by negative 1. So 2 equals N A intersect B. And that's all we have to do. This concludes section 7.2, Applications of Venn diagrams.